In this video, I'm going to show you how to use nmap to run port scans on remote networks. Before you start scanning networks, it's a good idea to scan, something that's not in production. Just a single test computer or some test network, and you can also use scanme.nmap.org. The developers of nmap set that up for the purpose of helping you to learn nmap. Nmap can send lots of packets across the network and to target systems. You can set up firewall alerts, IDS systems, and you can even fill up ARP tables on switches if they're not configured correctly. So, again, I strongly recommend, if you're learning nmap, find some test machine network. If you want to scan something in production, just make sure you get permission, or your supervisors know about it. So let me walk through the nmap process. It's important to know how it works by default. So by default, it runs through a host discovery process. So it tries to determine if the targets are online before it does any more in-depth scans to save time. So the best way to show you that is to run a port scan, and I'm going to use this packet trace option. And one thing I want to mention, all of these commands work the same in Linux or Windows. So if you're a Windows person and you want to play around with the map, just install it, and these commands will work just like they do in Linux or a Mac. It's ported over to several different operating systems, and the commands all work the same. So let me run this. So you can see here, this will output the packet sent and received. And you can see the top here, it's sent an ICM packet. It sent a TCP packet to port 443, another one to 80, and then it sent a timestamp request packet. These are all for trying to determine if the host is online. And you can see right here that the host received the packets. It's replying back to the sense saying, hey, yes, I'm sending this response back to my computer, and that lets nmap know that the computer's online. So to determine it's online, so now it will go ahead and do a port scan. So come down here, you'll see that my computer sent a send packet to port 21, and it got a response back. So this is important to know because a lot of computers and networks will have a firewall enabled that will block a lot of these packets that are sent during the nmap discovery process. So what will happen is, let me show you an example. I've got a computer that's online, but if I run a scan on it, or try to run a scan on it, it says it's down, but I know the computer's up. It just has a firewall on it that is blocking a lot of those packets that nmap sends to try to discover it's online or not. So what you'll have to do, what you may need to do a lot of times, is run nmap with this command -P-N. So what that will do will treat all the targets as online. It will skip the discovery process and then just go straight to a port scan. So I'll run this command again. And there you can see it came back with some ports open. And that's because I'm telling it to treat it as it's online and go ahead and run a port scan. So another important thing to know is this default command will scan the top 1,000 ports. So you don't have to put in you don't have to tell it what ports to scan. nmap has a file within the install directory that it refers to when running scans to, and it's got a list of the top 1,000 ports. So when it runs, it'll reference that file and automatically scan for the most frequently used ports. So, and real quick, I'll go through the TCP TCP three-way handshake. It's This is how computers make a connection. So when PC1 over here is trying to talk to server 1, it'll send a SYN packet, and server 1, if it's listening for packets on a specific port, say I'm trying to connect from PC1 to server 1 on port 21, and server 1 is listening on that port, it'll send an ACK back saying, yep, I'm listening, and then PC1 will send a ACK packet back. Nmap will use pieces of the three-way handshake to determine if computers are online and if ports are open or not. So with those basics out of the way, let me start with going through a bunch of examples. So on my website, I'll link to this in the notes section of the video, to this article where I've got all these examples, and I go through a bunch of technical stuff. If you really want to learn a bunch of technical details about nmap and some basics on networking, you can go through this article, or you can skip down here to the example section. That's what I'm going to go through right now. So, and some of these I've already kind of touched on, but if you want to just a quick and easy way to scan something, just do nmap and then the host name, or you can also use an IP address. So again, this will, by default, it's going to run a discovery process to determine if it's online, and then it's going to scan the top 1,000 ports. And there it comes back. It's determined it's online, and it found all of these ports. Well, let me go over one more thing that's really important, is the port state. So scan me, and I'm going to run the -P and then the port number. The -P, then you specify a port number is how you target a single port. But nmap has, I think, 6 different states that the port will show up as. So here I scan port 21, it comes back as closed. So if I use the packet trace, you can see I've sent packet to port 21, and the target system came back and said it received that packet. Or actually it received it, but it sends back a reset packet. That tells nmap that the port is closed. So I'm going to run another one to port. I'll just leave the packet trace off, but this is a great little option to help learn how nmap works. So now I'm going to run a scan to port 22, and this time it says it's open. So this means that the target system has an application running on that port that allows remote computers to make connections to it. And then the last one I'm going to show you is what you'll see a lot. Now this one says filtered. So filtered means that nmap sent packets to it, but it never got a response back. And that's typically because a firewall is enabled on the host or the network, or possibly both. A firewall intercepts the packet and drops it at the firewall and doesn't send anything back. So nmap has no idea if it's open or closed. So it puts it in the filtered state. So open, closed, and filtered are the most common port states you'll see, and open is really what you're looking for. You're looking for those systems that have open ports, because those are the systems that have applications running on them that can make connections where you'll find a lot of vulnerabilities. So let's go through a bunch of examples here. So I've already showed you how to scan a host. So what about a network? So let's say I want to scan my entire network. What I gotta do is go to the network. So this is a /24 network, 256 IP addresses in the network. So nmap will go, again by default, it's going to go and determine which ones are online. And then if it's online, it will do a port scan of the top 1,000 ports. So it did 256 IP addresses in 20 seconds. And you can see there's several computers on this network that it found online and scanned all of these ports. So you can also scan a range of IP addresses. So we'll start at 10 and then you just do a dash and then whatever. I'll do the next 10, so 20. So this will scan 192.168.100.10 through 20. And you can follow along with these, if you got a test network, or you can test these all with scammy.nmap.org. So I've showed you how to scan for a single port. So scan me.nmap.org. If you know the port you want to scan, just do -P and then the port number 21, port 80. Just put in whatever port. You can do multiple ports, so 21, 22, 39. Go ahead and run a scan on those 3 ports. And there you see it comes back with all 3 of those ports in the state that they're in. You can do a range. So the port dash, maybe I want to do the next 10 ports, so -30, so that'll do ports 21 through 30. A lot of times people will scan all ports, so to do that, just do P-65535, so that will scan all 65,535 TCP ports. And just keep in mind that the larger the networks, that's the scans a single host, so that probably won't take so long. But if I scan my entire network and all the ports, that could take a while. Another nice little way to scan systems is just by scanning the top ports again. This will scan map.nmap. Scan.nmap.org. That does the top 1,000. Maybe you wanted to do the top 100. You can do top dash ports, and then whatever you want to do. So top 100 ports. And maybe you want to do the top 10. So really easy to use. Start to specify, top ports. So that covers TCP. So if you want to do UDP ports, you gotta do -SU. And you don't need to memorize. There's so many commands. Like nmap has over 100 different commands, and it's hard to memorize all those. But you can reference these, on websites and stuff. And I've got lots of references and examples on my website. I've also got a cheat sheet too. So if you go to my website, you go to tutorials, click on nmap, and then I've got a cheat sheet here. So it shows you how to do different port scans, port scan techniques. So here's how to do a UDP port, how to do a UDP port and a TCP port. So it's just -SU and the port number 53, and then your target. And sometimes nmap requires root privileges. So again, that's how do you do a UDP port. So I've went through several examples, so you should have a good idea how to run port scans, how the default behavior works with the discovery process, how you may need to use the -pn option to treat all hosts online. So now let me go over a few tips that will help you when you start scanning larger networks. One thing I didn't mention, which is part of my tip number one, is nmap will run a DNS lookup by default. So if I ran scan like this on the entire network, it's going to go do a reverse DNS lookup on all of the targets. So let me make this a larger network and I'll show you. And I'm going to treat them all online. So when I run this, and you can hit the space bar to see the status. You can see right here, DNS resolution is in process, and it gives you the percent done. You can keep hitting space bar to see the progress. You can see it's kind of slow, so the DNS resolution is adding a lot of time to the scan. So you may want to turn off the main resolution and do that. Just do -n. So if I ran that command, it would disable any DNS resolution, which will help speed up scans for large networks. My next tip is disable the host discovery process, which we've covered that. Again, that's the -pn, which disables the host discovery process of all the targets. It will treat every IP address on this network as online and run a port scan on them. Just keep in mind, this will add significant time to your scans. So my next tip is displaying the progress during a large scan. So you can do this two ways. You can just hit the spacebar to get the status, or you can enable this command stats every. And let me give you an example. So I'll run a large scan here on this /16 network. Treat all hosts online, and then I want it to display the stats every 10 seconds. You can do seconds or minutes. So without doing anything, every 10 seconds, it will display to the screen the status of the scan. So there it popped up and said it's doing the resolution process. It's 8% done. The minute, 42 seconds remaining. And then there it is again after another 10 seconds and gives you an update. So again, you can just hit the space bar, but it's kind of nice to have it automatically display the status. My next tip is using the packet trace, which I've went over already, but it's a great command. nmap. It displays the packets nmap will send and receive, so it's a great little option to help learn what nmap is doing in the background. It also helps to troubleshoot. In case something's not working right, you can see what nmap is doing to help troubleshoot it. My tip number 5 is to use the reason command. So this command will show you why a port is either blocked, closed, or filter, or whatever. So scan. And then I'm going to do port 21, and then reason. So here, it tells me the port's closed for this reason here. Let me do another port. And here it says it's because of the SYNAC. That means that it's saying it's open because it got a SYNAC packet back. My tip number 6 is to run a ping scan first. And I've got a complete guide on this of doing just a host discovery. So if you're doing very large networks, it can take a really long time, hours and hours, maybe days to complete large scans. If you're using the default discovery process, treating all hosts online. So what you may want to do, which I think is a good idea, is to first run some ping scans to determine if the computers are online. Then you can gather that list and then send that list to nmap and do port scans and more in-depth scans just on those hosts that you found active. That will really speed up your testing. I won't go over that because I've got a whole guide on that. I got links to it here in that post discovery process. So my last tip is saving your scans out to a file. So just do a quick example. You do that with -o-in and then the file name. We gotta have permissions first. So in Windows, you would just specify the path. On Linux here, it's going to default to my home directory here, scanme.txt, and you can open that up with an editor and view it. nmap has some other options too for scanning. You can scan it out to a searchable file, and you can also output it to 3 different files, but you'll want to output it to a file on very large scans. That way you can go back through and filter it and do all kinds of stuff and save your scans. So the last thing I'm going to do here is run a large scan with a combination of all the things that I went through. So I'm going to run a scan on this entire network. I want to treat all hosts online. I want to disable DNS lookups. I want to display the stats every 10 seconds. And then I want to output the scan to a text file. So this will scan this network. It's going to treat all those online, so it'll do a port scan on the top 1,000 ports. Disable DNS resolution to help speed up the scan. I want to see the stats every 10 seconds and save the scan to this text file. I entered something wrong. I had the one of the commands wrong. Dash lowercase 0 or O and then uppercase N to save the file. So we'll pause this. This will take a few minutes to run. Well, actually, we'll let it display the progress on the screen. There we go. It already says 67% done. 4 seconds remaining. So there, it only took 20 seconds to scan 256 IP addresses and it scanned the top 1,000 ports on all of these hosts. So you can see it found 8 hosts up. Here's one computer. It's got port 53, port 88, open, Kerberos, LDAP, global LDAP. So just by looking at these services, this is probably a domain controller. And this computer here looks like it's running some of the same ports, maybe another domain controller, a third one. And then this computer is running port 80, and these are some Microsoft ports. This port has 3389 open. That's Remote Desktop Services, RDP. And then this computer here has got port 21, FTP open. So that's probably not something that needs to be open, but I think you get the idea. It's pretty easy to run scans. I showed you how to run scan to find the top 1,000 ports, how to specify ports. Um, Again, very easy to use. nmap has tons and tons of command line options and scanning techniques. I really just went over some basics on port scanning, but these basics are very powerful. As you can see, you should be able to find computers with open ports with these basic commands that I showed you. Um, and if you need a reference, please go to my website, netlinko.com. You can go to tutorials, and you can easily filter on any type of tutorial you're looking for. Find all the nmap stuff. You just click the nmap filter here. I've got a bunch of guides on nmap. I've got more coming. I've got a cheat sheet again. So if you need a reference for commands, please check out this cheat sheet. That's it for this video. Thanks for watching.